Hi students, today we are discussing about diffraction due to end slits. Up to now we are dealing with the single slit, double slits. Now let us see what will happen when we are using n number of slits for our diffraction pattern. Let us see. An arrangement consisting of large number of parallel slits of the same width and separated by equal opaque spaces is known as diffraction gradient. Means the slits are arranged in a parallel and those are separated by equal distances, equal opaque spaces. Opaque means which is not a transparent. And gratings are constructed by ruling equidistant parallel lines on a transparent material such as glass with a fine diamond point. So the distance between the slits, between the lines is equally designed, and the ruled lines are opaque to white light while the space between any two lines is transparent to the light and acts as a slit. So the line which we are dividing the slit into equal parts, that will act as opaque medium. That means it is not transparent. And between the lines, the space, that is a transparent medium to the light and which acts as a slit. So this is known as plane transmission gradient. When the spacing between the lines is of the order of the wavelength of light, then the appreciable deviation of the light is produced. We already know that uh, the size of the obstacle must be compared with the wavelength of the light. Here also the spacing between the lines, that is comparable with the wavelength of slit, then we can get the appropriate diffraction pattern. Okay, let us see what's the theory behind this. So a section of plane transmission grating AB is placed perpendicular to the plane of paper as shown in the figure. See, let's W dash is a wavefront and AB, that's indicating the slits and number of slits, and here XY is a screen and the deviation angle is a theta. P0 is a maximum intensity and P1 is a minimum intensity. That means P0 is a central maxima here. So let E be the width of the each slit and D the width of the each opaque space. Okay, that means E plus D is the separation distance, and that is known as the grating element that grates each and every slits. So E plus D is known as the grating element, and XY is the screen. Suppose a parallel beam of monochromatic light of wavelength lambda that is incident normally on the grating by Huygens principle. We already said that about Huygens principle. What will happen? Each of slit ends secondary wavelets in all directions. That means each point on the wave, primary wave, will act as the secondary source for the wavelets. So now the secondary wavelets traveling in the direction of incident light will focus at point P0 on the screen. So the main thing is the secondary wavelets traveling along the incident direction, incident light direction also, and they will make a central maxima P0. Now consider the secondary waves traveling in a direction inclined at an angle theta with the incident light which will reach at point P1 in different phases. So the angle of deviation is theta and P1 is a another point that gives us a maxima or minima. Okay, as a result, dark and bright bands on both sides of central maxima are obtained. That means whenever we are using a monochromatic source, we can obtain the bright and dark bands. So while we are using the polychromatic light, we can get the Vibgyor colors as orders with the having intensity variation. Okay, now the intensity at point P1 may be considered by applying the theory of Fraunhofer diffraction at a single slit. See, uh, in due to single slit we are getting only diffraction pattern, and according to double slit we are getting both interference and diffraction pattern. Okay, now what will happen? What will happen here also? the same theory applicable. What will means the wavelets proceeding from all points in a slit along the direction are equivalent to a single wave of amplitude A sin alpha by alpha. That is the amplitude of each wave, and starting from the middle point of the slit. That means where alpha and alpha value we are considering from the path difference, we know that value of alpha equals to pi by lambda into E sin theta. Okay, and next, if there are n slits, then we have n diffracted waves. We already know we are using n slits, then the rays will be diffracted in number of waves. So the path difference between two consecutive slits is E plus d sin theta. So from here we are taking the phase difference also. Phase difference means delta. Delta equals to 2 pi by lambda plus into E plus d sin theta. We are having the phase difference like 2 pi by lambda into path difference. So now the pi by lambda into E plus d sin theta is considering as beta according to the double slit. Okay, now here the intensity in a direction theta can be found by finding the resultant amplitude of n vibrations, each of amplitude A sin alpha by alpha, and a phase difference of 2 beta. So the wave which we are getting from n slits, n number of slits, amplitude of each wave is same, A sin alpha by alpha, and having a phase difference. There is a phase difference. Why? It means we already discussed in the single slit. So we are having the phase difference of 2 beta. Now at the case in previous case, all in present case also we are taking the terms as alpha equals to A sin alpha by alpha, A equals to A sin alpha by alpha, that means amplitude of each wave, and n equals to n, that means we are using n number of slits, and delta equals to 2 beta has a phase difference. Now we already know about the amplitude, resultant amplitude from the vector addition. R equals to A sin n delta by 2 by sin delta by 2. Here we are substituting the above terms in the equation for the resultant amplitude on the screen at P1. So now R equals to, we are replacing small A sin alpha by alpha into sin n beta, because delta equals to 2 beta. Now from beta, delta by 2 equals to beta. So R equals to A sin alpha by alpha into sin n beta by sin beta. We are getting the new equation. So this is the intensity. We know that square of the amplitude gives the intensity. So from this resultant amplitude equation, we can write the intensity equation. So the intensity at P1 will be I square. P1 will be, that's not I square, it's I equals to R square, that equals to A sin alpha by alpha whole square into sin square n beta by sin square beta. Here let us see. The factor A sin alpha by alpha gives the distribution of intensity due to single slit. We already know that this is a factor according to interference. And while with a factor sin square n beta by sin square beta gives the distribution of intensity as a combined effect of all the slits. Okay, and now let us see. This is the intensity equation. It's the principal maxima. Let us see how the intensity will distribute in the case of principal maxima, secondary maxima, and minima conditions. Let us see first case, that's a principal maxima. That means the equation 2 will take a maximum. That means for the condition of principal maxima, sin beta equals to 0 but not sin n beta equals to 0. So beta equals to plus or minus n pi, plus or minus n pi. So n equals to 0, 1, 2, 3 and so on. Pi by lambda into beta value, we are substituting the beta value, pi by lambda into E plus d sin theta, that equals to plus or minus n pi. Now E plus d sin theta equals to pi gets cancelled here. Now plus or minus n lambda. Here for 0, whenever n equals to 0, we are getting a 0 order maximum. For n equal to 1, we are getting first order maxima, 2 second order maxima, like that. For n equals to 1, 2, 3 and so on values, we are getting the first, second, third principal maximas respectively. We already know that there is a minima between two secondary maximas and there is a secondary maxima between two minimas. So here the plus or minus sign indicates that there are two principal maxima of same order lying on either side of zero order maxima. So beside the principal maxima, we are having the same order maxima. Here the plus or minus indication is only that. Okay, see, when minima positions, what is minima positions? Here when we are taking sine beta equals to 0, again we are getting the principal maxima condition. So now we have to know about minima condition. So equation 2 that takes will maximum value. So minimum value means sin n beta equals to 0, but sin beta equals to doesn't equals to 0. We are getting that point especially. So now therefore n beta equals to plus or minus m. So sin beta equals 0 అయినప్పుడు beta e plus or minus n pi అవుతుంది. Like that sin n beta equals to 0, therefore n beta equals to plus or minus m. If we are taking that as n, that is there is no problem, and n we are substituting the beta value. Again here we are getting a condition. See, where m has all integral values except m equals to 0, n, 2n, nn and so on, because for these values sin beta becomes 0. For these values sin beta becomes 0. What is the condition? Whenever the sin beta is 0, automatically we can get the principal maxima. There is no minima condition. So for this only 0, n, 2n and up to n into n, that n into n, then becomes the principal maxima. So for that we are taking m equals to 1, 2, 3 and so on up to n minus 1. Up to n minus 1 we are getting the minima positions. Whenever we go for the n equation, whenever the value of n equals to n, here we are getting a principal maxima condition. Okay, see, now we are substituting. That means where m equals to n minus 1, n plus 1, there is no condition of n minus 1 and n plus 1, there is no condition of n, and up to 2n minus 1, like that. This gives the minima positions which are adjacent to the principal maxima. Case 3. Now secondary maxima. As there are n minus 1 minima between two adjacent principal maxima, you should understand, you have to understand that sentence completely. As there are n minus 1 minima between two adjacent principal maxima, there must be n minus 2 maxima between two principal maxima. They are known as secondary maxima. Okay, that means whenever we are having n number of slits, okay, so principal maxima, there is a condition of principal maxima n, we are having n minus 1 minima and n minus 2 secondary maxima. Okay, for example, we are having 10,000 slits, so 10,000 minus 1 minima conditions is there, 10,000 minus 2 secondary maxima conditions is there. So that is the meaning of that sentence. So for the secondary maxima conditions, we have to differentiate this condition, especially di by d beta equals to 0. So from here, from the differentiation condition, we are getting these conditions. In this condition, particularly sin alpha by alpha doesn't equals to 0, like that sin n beta doesn't equals to 0, then only the numerator term, the last numerator term will equals to 0. From that condition, we are getting n tan beta equals to tan n beta, because like terms are, we can write the like terms on same side. So n tan beta equals to tan n beta. We have to find out the condition sin square n beta by sin square beta value. We have to know that. For that, the roots of the above equation, that is beta value equals to plus or minus n pi, which gives the positions of secondary maxima. From this tan equation, we can write the sign condition. See here, tan n beta equals to n by cot beta. That means we are writing tan as cot. So we have to understand this triangle from the above equation. From the triangle, we have sin n beta equals to, sin means opposite by hypotenuse. So n is the opposite by hypotenuse, root of n square plus cot square beta. From that, sin square n beta we can write by sin square beta. So n square by root square gets cancelled into sin square beta. So sin square n beta by sin square beta equals to, we are getting these terms, and here we are writing cos square beta as 1 minus sin square beta. You have to understand that because cot square beta into sin square beta, we are getting a cos square beta value. So cos square beta we can write it as 1 minus sin square theta from the trigonometry equations. Now we are getting common the sin square beta term. So there's a final intensity equation, I equals to I naught into sin square alpha by alpha whole square into n square by 1 plus n square minus 1 into sin square beta. So since the intensity of principal maxima is proportional to n square, that means as the number of slits increases, the intensity also increases. That means I is directly proportional to n square. From this we are getting a ratio intensity of secondary maxima to the intensity of principal maxima. Okay. So now the equation becomes 1 by 1 plus n square minus 1 into sin square beta. If the value of n is larger, then the secondary maximum will be weaker and becomes negligible when n becomes infinity. Here in this graph, we are particularly showing the principal maximas. That means zero order principal maxima, first order principal maxima, both sides for the zero order. Alage like that there is a minima conditions, secondary maxima conditions is also. That means total n minus 1 minima conditions, n minus 2 secondary maxima conditions between two principal maxima. Okay, thank you.